My name is Debbie Burke. I used to work with CRIN, and then I went over to BBA Engineers. I want to thank Justin actually for shouting out North Star Clean Technologies. We were the engineer for that project. And so it's pretty cool. We do support innovators in their pilot projects, and then all the way beyond. It's not just innovators. We also support any heavy industry with their projects and advisory services. Now, I have a real nice connection to Catheros because the first panel I hosted with Corinne was for Catheros. I think Catheros has an extremely amazing story. I'd like to welcome Mitchell Jones, and he will do a finer introduction of himself and Catheros. Time clock starts at 12:03.
Sounds
You
good.
have 20 minutes.
All right.
Let's hear it.
Okay, thanks so much. Thanks for the introductions. Hi, everyone. My name is Mitchell Jones. I'm with Catheros, obviously. I'm a technical account manager here. I've been with the company for just over 3 years. I started in 2022, kind of just when the company was getting ready to get going commercially. The company was initially founded in 2020 by Dick Brown, and there's a pilot project started in 2021, which ran successfully for multiple months. And then kind of 2022 timeframe is when commercial operations got started. Initially, the company kicked off with Ovintiv in Canada, and also ExxonMobil in Pennsylvania were kind of the main footholds for starting the company. And since then, we've grown rapidly over the past 3 years, basically operating in every oil and gas basin across the US and throughout Alberta. So the problem Catheros is focused on solving is, sorry. The problem we're focused on solving is methane venting. There we go. And methane venting from pneumatics specifically. So from the upstream oil and gas sector, approximately 45% of emissions come from, or 45% of emissions come from the upstream oil and gas sector. And of those, it's estimated that about 20% come strictly from pneumatic venting. And for those who aren't familiar with pneumatics, it's instrumentation devices that are used at well sites across the country and throughout North America, and they basically control the oil and gas production, temperature level, pressure control. So they're essential for all pneumatic production and widespread across industry for a long time. But part of how they work is they use typically methane gas from the well site to operate. They use the pressure to move the pneumatics. So these are basically at every oil and gas site. Initially when we started the company, we were focused on the remote sites that didn't have access to power or a way to convert these devices to another technology. So that's where Catheros comes in. And as well, not only do they vent gas, which is not only bad for the environment. Methane's estimated to have a 28 times global warming potential compared to CO2, but there's also some pending regulations across Canada and in the US. And just in North America alone, it's estimated there's 400,000 plus sites that are venting. Those could be single well sites, multi well pads across the country and throughout the United States as well. So there is some federal draft policy framework that was introduced in 2023, which proposed zero venting across pneumatics by 2030. That hasn't been finalized yet, but that's one thing that operators are well aware of and trying to figure out a way to address these emissions from pneumatics. And historically, they've been hard to address because lots of sites are remote, meaning they don't have access to power. They don't have a power source on site, and then some of the alternative solutions that are out there. Solar power in Canada is obviously can be challenged in the winter. So Catheros technology kind of took a different approach to the pneumatic conversion solution. As I mentioned in the past, lots of it was focused on converting pneumatics to instrument air solutions, converting them to solar power, running them with electric devices if there was access to power. And where Catheros came in, we basically, instead of changing out the device or installing a bunch of different technology, we just basically switch the fuel source to nitrogen instead of using the fuel gas, we will install a nitrogen tank on site. So you can think of it's very similar to a propane model that is used for heating homes or used at various oil and gas sites as well for a fuel source. So we essentially will install a nitrogen tank, which is pictured there. It's a cryogenic vessel. And this nitrogen will basically provide the gas power required to run the pneumatic devices. And then you're venting nitrogen instead of methane, which is an inert gas. So there's no global warming potential. Some of the key benefits I mentioned, lots of these sites are remote, so they can be challenging economically to convert. And in Alberta, we have the carbon offsets, which help provide some economics on those sites. But for even new facilities now, you can't be venting from pneumatics, so it's kind of you have to choose between using electric and air, or solar powered solutions or the nitrogen. So some of the key differentiators between the nitrogen products is it's no moving parts, so it's literally just a tank powered completely by thermodynamics. So very little maintenance. It can be used at remote sites. We don't need any access to electricity, any grid power, anything like that. And then also, we have very reliable and verifier grade data on our system. So it's essentially a closed loop tank. So everything that's leaving the tank is being used to power the pneumatics. So we know exactly how much gas is leaving the tank, and thus we know how much methane would have otherwise been vented. We use a gas equivalency ratio, which basically adjusts the nitrogen usage for the amount of methane that would have been vented. And with that data, we can use it for, companies can use it for ESG reporting, or in Alberta, the carbon offsets, our data is verified to be used to determine how much carbon credits can be generated on a site. So yeah, again, just back to the no power, here's a few examples of our installations, one in Canada, and the one on the right there is one of our first sites in Pennsylvania. So the solution is very simple. Allows us to address lots of sites, that maybe would be economically challenged with other alternatives, and also quickly because the tanks can just be set directly on the ground. There's not a lot of setup that needs to happen at site. So, when you consider the regulations that are pending in Canada, and then also the regulations in place in the US, companies are trying to figure out how they can convert, hundreds or thousands of sites in some cases to zero venting from pneumatics. And this is where the tank is a great solution for that. It can just, it sits directly on the ground. There's not a lot of site prep that needs to go into it. Yeah, so I mentioned we have 6 different sizes of tanks, and we basically size them so they are refilled monthly. So we have a whole fleet of dispatch trucks. So obviously the nitrogen will deplete over time, and we'll size the tanks so we fill them up approximately every month, and that's all managed by Cathero's team. So we have different sizes so we can handle different demand of well sites, anywhere from like single well sites up to large pads or even facilities, compressor stations. We've installed tanks out with customers. And that's really the benefit, as well as we can have the flexibility of the system. So some customers are worried about converting older sites that maybe might not even be operating in a few years. It's nice because the tank is it's a lease model, so we drop it off, fill it up, and then if the customer doesn't need it because the well is not economic to produce or something changes with their plans, it's easy to move the tanks, change the sizes on our side. And yeah, I mentioned the data. So all of our tanks come with basically a telemetry unit, which allows us to track the temperature or the level and pressure in the vessel at all times. So this is really beneficial for our customers as well, because it really takes the issue of methane venting off their hands. We completely manage everything from the dispatching, the tank monitoring. So once the tank's installed, they really don't have to think about it anymore, and it's kind of that problem's been solved for them. So we're working with many companies, to do large campaigns that want to address a large batch of sites, whether it's to get offsets, or just meet like corporate goals for ESG and reduce their methane emissions. And then just recently, we've upgraded our internal data tracking system. We released a dashboard that's called Atlas, and this is connected to all of our tanks. So this is really where we can we can use that verifier grade data and provide it to our customers so they can show how much methane they've been eliminating, and they can prove it to, whether it's the offset process for their own internal reporting. All that data has been verified, and then they can use that. So we created our own platform that basically allows our customers to access the tank levels at all times, as well as the nitrogen usage, which can be converted to the ton CO2e equivalent. And just we have a tracker in our office, and since the company's been started, we've eliminated over 700,000 tons of CO2e equivalent, which in 3 years is quite significant. That's across about 2,500 sites operating throughout Canada and the United States. And I think just yesterday alone, it said there was 1,400 tons eliminated. So every day we see the impact, and it's every time we add a tank, we can see the data and what the impact the technology is making and helping solve the methane, the methane venting from upstream oil and gas. Yeah, and as I alluded to it, this is the data counter we have, but it does, it does track it every day, and it's really interesting to see, and I think our customers appreciate the insight they do. And we do also get a lot of questions. Basically we're trucking nitrogen to all these tanks. People ask, well, what is the emissions related to that? You're eliminating methane venting from pneumatics, but what is the impact of trucking nitrogen all over the country? And we did the exercise, the life cycle assessment of how much emissions would be emitted in our process, and it's less than 2% of the total emissions that we mitigate. So pretty insignificant, but it is something that we do track and we are aware of. So even on an offset side, particularly, we have to keep track of that. So that's also built into our data system and our offset tracking, and also our Atlas dashboard. So in the grand scheme of things, it's quite insignificant, but there's there is some venting as well. Yeah, and that kind of covers it. I guess I'll open the floor for questions.
Hi, I'm Kate Easton, an independent consultant. Just a question about the cost of the nitrogen versus the value of the natural gas.
Yeah. So the cost of the nitrogen, it is quite cheap, less than the natural gas. Our system is basically there's a rental for the tank, and then you just pay for the amount of nitrogen consumed. So it's companies weighing not only the cost of natural gas saved, but then also if there's a cost associated with the venting, and then the carbon credits. So
Okay, no, I was just wondering, without the carbon credits, is it still more cost effective to use the nitrogen than to use natural gas?
I mean, it would depend on the area and what the price of natural gas is. In Alberta, it can vary. I know in the States where gas prices are different, it is, it's a different story. It definitely the system can pay for itself by the amount of gas used. But, in Alberta where the gas prices are a bit different, it does become challenging economically, and that's where the offsets really help. But there's also some benefits to the system too that aren't directly tied to just offsets, because it's an inert dry gas. There's no issues with even, instrument air or just fuel gas that companies are using. They have troubles with, freezing in the winter, and then that causes downtime at their sites. So we try and help our customers understand that, you're not just saving that natural gas that would have been vented, but you're also saving production when you don't have to worry about equipment breaking down due to moving parts, or you don't have to worry about freezing of propane, fuel gas, or air, whatever they could be using. So there's various different factors that go into it, and that's partly where our data comes in as well. Like over 30 million operating hours, we have 99.99% reliability, and we know that just because we have all the data for the tank. So there's a huge economic benefit, even not considering the gas saved or offset credits.
Could you speak a little bit more to the road to adoption, or the technology development side of it?
Yeah, so I think I mentioned the technology was initially trialed in 2021 at a pilot site, which operated flawlessly for 6+ months in Alberta. And then the technology really got kicked off with CRIN here in Alberta. There was a project with Ovintiv and Cenovus in 2022 where we installed about 90 tanks with between Ovintiv and Cenovus, funded with help from the CRIN funding program. And then as well at the same time in the US, we started with ExxonMobil in 2022, and we did another 70 sites in converted 70 sites in 3 months in Pennsylvania. So that was kind of the start of the company, kind of around the time that I joined, and since then it's really scaled, across Alberta and the States. The US had some pretty, or still does have some more aggressive legislation that doesn't allow venting at sites. So we've grown to approximately like 2,500 sites and just in 3 years in the US. And then in Canada, we're up to close to 250 sites, which is driven by companies that want carbon credits, companies that are trying to meet corporate emissions goals, or also companies just converting even new facilities that can't be venting methane anyways. They've been using our technology to run the pneumatics at their brand new sites just due to the reliability aspect I mentioned. They don't have to worry about rotating equipment or solar powered running their devices. They can just rely on our tank. Our guys handle all the maintenance. So that's really where we've seen lots of the growth. There's kind of been 3 buckets: a regulatory, a carbon credits, then kind of on the reliability side. That's why companies have kind of decided to go the Catheros route.
One of the things a couple of years ago when I was listening to this presentation, it's one of those, once you find out about the Catheros solution, you're like, well, yeah, duh. Why haven't we always been doing this? And I think for me, it was okay. Yeah, that it makes a lot of sense, but you have to back everything up through what's the supply chain. So I'm not sure if you want to talk a little bit about not necessarily the supply chain of nitrogen, but that you've got to have an infrastructure or a known infrastructure. You have to understand how an adjacent market or your supply market works. I may be filling in the gaps already, but why don't I just hand that to you, talking about nitrogen, how you get nitrogen reliably and every day to the site, if
Yeah.
that makes sense.
Yeah, that's a question we get a lot as well. Customers, we deliver the nitrogen, but they want to know where we're getting it from and confirm that we can get it when they need it. So Dick Brown, I mentioned, who founded our company, actually founded Ferris previously, which was a large industrial nitrogen producer. So the nitrogen supply chain is very well developed in Canada and all across the US. In Canada specifically, it was built out for oil and gas frac industry, and that demand has kind of waned over the past 10 years. So there is a massive oversupply of nitrogen in Canada specifically. And we have agreements with Ferris, who's a large provider, and many other industrial gas companies that supply nitrogen to our storage facilities, and then we're delivering that to customer sites. And same thing in the US, nitrogen is very widespread. It's kind of a byproduct of companies trying to get oxygen or other gases for medical use. So, it makes up 79% of the air. So there's almost a massive oversupply. The price really doesn't fluctuate and hasn't for a long time. So that's where we can be certain that we can get the nitrogen when we need it, and keep the costs low and deliver it to our customers on time and when they need it.
Thank you, Michelle. Did a good presentation. I'm just going to build on Debbie's question. So did they say there's not why are people not doing it? And that resonated with me. So I'm curious to know, what's the competitive landscape? Are there other companies doing what you guys are doing right now? Thank you.
Yeah, so I mentioned some of the competitive technologies. It's instrument air, solar powered, companies even just removing devices using propane. So it does come down to a few factors. Some companies have initially started out on instrument air route because that was kind of the first option. And there's challenges with that. As I mentioned, it's rotating equipment, so there's lots of maintenance involved from the customer side, and obviously there's a cost to that maintenance. Solar power, in the southern US where sun's abundant, it maybe works a bit better, but here, on today, we have many customers where they lose multiple days at a time. So it's really weighing, and as I mentioned as well, ours is a lease model. So the customer they basically rent the system from us. We deal with everything and all the refills. So it's kind of just customer preference on whether they want to buy and manage equipment and have to worry about maintaining it, or they just want to put it in our hands and let us do it. And as well on the offset side, that's a service we offer as well. So it's kind of it's a package deal. So it kind of comes down to, we have lots of customers that have started going down, instrument error routes, solar routes, and then came to us because of reliability concerns or just, the large upfront costs required to install that equipment and the site prep that you have to do. Whereas ours is, it's setting down a tank and then it gets refilled. And if something changes in the future, it can just be removed. So the simplicity and just the scalability of it, I think, is kind of what some customers value.
Do you have a specific competitor in the nitrogen tank market?
We do not have a competitor in the nitrogen tank market. Many customers have tried using nitrogen gas bottles. So maybe I didn't clarify that well, but like what makes our technology different as well is it's liquid nitrogen, so we can store a lot of gas in the tank. So lots of companies have tried doing gas bottles, but the problem with that is it holds very little volume, and then it's quite intensive to move bottles around, whereas we're hauling a lot of liquid at once. So there is that option out there, gas bottles, which is typically used for very small venting sites. But no, we don't have a direct competitor doing a similar thing as we are.
That's awesome. Thank you very much for your time today. I think we're at time and we're going to move along to the next one.
Sounds good.
So
Thank you.
let's round of applause. I believe the microphone's on.
Yeah.
You're just going to, this is the big button.
Yeah.
But point it towards them
Towards there.
to advance because that's where the computer is. So you just.
Yeah.
All right. Next up, we have Innotech and we have Dr. Oh, I just. Je- I'm really not good with X's and names here, but Xiaowei Deng. And if I did that wrong, he's going to do that. So welcome to the stage.
Thank you. So my name is Xiaohui Deng. I'm expert research at Innotech. I've been working in Institute of Process Technology Development for 20 years. Today we are going to talk about the CRIN supported project that we have been developing. It's a low energy intensity in situ recovery technology called warm DME injection gravity drainage bitumen production process. Okay. So this technology, it's involved injection of vaporized DME. DME is a dimethyl ether, and the water at a low temperature, really below 100 degrees C, with a similar wear configuration as a CCD. So we try to deliver similar economic performance compared to CCD, and at the same time, the direct GHG reduction will be 80% plus direction GHG reductions. And also we use much less water, 80% of the water, 20% of the water at CCD using. This just shows how schematic how the process goes. You are injecting a warm DME water and then vaporize and dilute oil and drain down and produce in the production wells. With their CRIN support, we have done semi-field semi-field scale physical model experiment. We compare these two. One is the warm DME injection, which we are injecting at 80 degree and operating pressure 2100 kPa. And also we did a CCD test experiment, same physical model, but the temperature will be 210 degree and at 2100 kPa. We're using a field sand, so it's 4 Darcy, 5 Darcy sands with a sparse bitumen. So if you look at the curve, it shows the CCD and DME, their oil productions vary. It's almost similar. Actually, at the same period, the DME process faster than CCDs. So the project We have been developing the DME process since 2016. So at the point when we apply the green funding, we are kind of at TIL6. So the main project of the CRIN project, the objective is really to advance the technology to TRL7, completing experiment, doing some engineering analysis to assess the viability for the commercial application of field preliminary field test design. So that's our objectives. So as I just said, so one task is really we do the physical model test. The other task of the project is field scale simulations performance. We developing tools, prediction tools. So how do we do that? So we have experiment and we history match the experiment and we capture the simulation, the key process mechanism in the simulation, and then we scale up to the field scale simulation. That's how we do the field scale simulation performance prediction. So we develop the tools and then kind of have a process at field conditions. So how much DME needs injected and how much oil production in a single well as a secondary well pairs. Single well pair also production rate and the solvent oil ratios. So here just the numbers shows the plot shows the performance. Another task we have is the initialization. You know, the SECD process, you need steam circulations. So in this case, if we don't have steam, what are you going to do with the process to initialize the process between the injection well and the production well? With SECD, you do steam circulation with heat conduction, heat transpose. Then you dilute the oil between the well, the injection well and production well, then you can start the SECD. In the DME, we are doing similar things, but we are change that a little bit. It's not circulation. It's actually we are doing alternative cyclic steam injection in both the injection well and the production well to try to effectively mobilize the oil between the injection well and the production well. So we have a scheme. Within 4 months, we can build the communication between the injection and production wells. And we actually also did a 2D experiment to verify these ideas, the ideas. So, of course, the lab, we have a small, it's not 5 meters between injection wells, it's 1 meter between injection wells. With our model approaches, we were quickly build, we were within 36 hours, we were able to build the communication between the injection and the production. So this is one. So this is our process initialization schemes method we developed for under the CRIN project. Another part is process optimizations. So really, you want to get the oil, similar oil production as SECD, but at the same time, you want to recover the DME, the solvent DME as much as possible. So we operating, consider the operating parameters like water concentration in the injections, injection temperatures, operating pressures, and with NCGs in the later stage of process, if we can improve, increase the solvent recovery. So we the observation we see that is with increased operating pressure, you have high oil recovery, and but with decreased operating pressure, you have actually lower steam oil ratio. Lower DME oil ratios. Another task is preliminary design. cost estimation of the surface facility for this process. So based on the simulation results process, we developed process scheme, surface facility schemes with field scale simulation results. And then we did a class 5 cost estimate. So for 15 barrel per day bitumen pilot, the surface cost is between $6 to $23 million. If it's 14,000 barrel per day of commercial operations, the cost estimate, capital cost, is $93 to $372 million. If you look at the compared to SAGD, this is much less than SAGD. The other fact we checked the environmental impact of DME in situ. So based on the DME properties, regular requirement, and the potential environmental impact, DME is actually a safe solvent for use in situ bitumen recovery. But of course, safety protocol as just other solvents to be used in in situ process, you need to be in place. Over there, the project period, we have 2 patent. We have one patent filed, and also we have another patent already granted. So next step, we are thinking the next 5 years, we are working with operators to try to form a consortiums and to engage the operator to do a field pilot. So try to advance the TIR level from 7 to 8. And then 2030, really it's between, we need to get DME. So we did taking a initial agreement with the DME producers and engage them to commit to producing DMEs. And we hope by 2035, we can start to see a commercial oil production with the process, and 2038, maybe 5% of the in-situ bitumen production it's come from this process. I think that's it. Thank you.
Okay, thank you very much for that. Yeah, we can clap. You want to clap? Let's clap. Do we have any questions here in the audience?
Thanks for the presentation. I'm Mariam Omidwar from Etox Energy. Based on the 2 days panel and your presentation, I kind of just trying to wrap up everything. And you mentioned that the project wasn't going to get to TRL6 with the support from Alberta Innovate and the CRIN from 2016. My question is not more on the technology side, in a broader aspect, that in the panel in the morning, we were hearing that the roadblock is not the adoption. It's not developing the technology, but it's more in the adoption of the technology and getting to a market. I was wondering, during the past few years that you were focusing on the technology readiness, how did you tackle that, the market adoption, or how did you engage the industry and get their interest to invest in your technology or adopt it and be first one to try in the field, which is in your next year plan to go to a field test? Is there any specific oil and gas industry backing this technology? Thank you.
Thank you. I forgot that actually there's a page after this one. So the acknowledgement. So in the acknowledgement, actually, we are engaged the operators, including CNI, Imperial, Sunco. Those are actually supporting this project and partially funded this project. So we have been engaged with them, and I know one of these operators are actually considering pilot. So we are providing technical information to them now, regarding the process.
Okay, I could ask a question. And then my mind goes blank. That's what happens sometimes. Yeah. Right? Oh, yes, okay. I was thinking about, based on your simulation, do you have, and you had a graph there that showcased, traditional SAGD versus using DME as part of this. Do you have and then you also went in to talk about like that kind of pre-circulation and how you can pre-treat the reservoir before you start injecting steam as well. Do you have a preliminary or solid recommendation for an operator, and maybe it's area specific, but how they should operate either in start mode, in steam chamber development mode, or in typical long-term production development mode? There a recommendation of you should do this at this stage with DME to make sure you get the most of your reservoir, and maybe you have something on that, or maybe no.
You mean
like how they would change their operating practices within their reservoir to include DME? What would be the first thing that they should do to see the best results?
So I would say actually, if you start with a greenfield right away, start with that, probably you can get the best benefit of that. You don't, as I just mentioned, that you don't even need to build your steam facilities, water treatment facility, and the capital cost will be saved a lot. So that's what I recommend.
Okay, so that's kind of in line with your simulation results that show that you can recover. We went back to that slide, but we don't need to go to that slide, that you can recover oil quicker if you use it right from the very beginning.
Yeah.
Did any of your simulations showcase if you pre-treated, pre-soaked your reservoir, and maybe I'm connecting dots that I don't need to be connecting here, but is there an advantage to pre-soaking your reservoir to accelerate steam chamber development? Is that what that's actually doing? Or, I mean, I just feel like there's a lot of different stages. You can pre-soak, you could just put it into the steam right away. You could wait till your steam chamber's developed, and then you can start injecting. And so I'm just trying to understand a little bit more about, like, if I was an adopter and I wanted to do the least risky thing to get the best results to prove this out, what would you recommend?
So I see probably I didn't explain that well. So the process itself actually not need any steams. We don't need steam.
Okay.
Yeah. So it's not add solvent to a SAGD process. This is a pure, we call the thermal solvent process. It's just DME. It's just DME. Why do we need the water there? Is because DME have a very unique properties. It dissolved in both in water and oil. So in the reservoir, because it dissolved in both water and oil, it actually helps the mass transfer within the reservoir significantly. It's because it transfer within the water and also transfer. So we don't want the reservoir dry out with no water, then so the water add that is really continue facilitated process. It's not because of winter. So for me, the process will start right away
it's just a complete replacement. I'm sorry I missed that.
Yes, sorry I didn't explain that.
No, it's maybe you did and I just missed it. So that is really interesting. So I think we're probably at time though, but can we take one more minute, Lindy? So you have I'm going to make an assumption here. There is a large environmental benefit because now you don't have to have steam, which is a very energy intensive process.
Yep.
And this would be more, it's liquid, or is it gas?
It's still vapor.
It's still vapor. Okay.
Yeah.
Okay. So there's still some additional energy inputs more than pumps, but it should not be, you're not heating this the same. Okay. Excellent. there's no other questions. I have no other questions. I'm glad that I got crossed that barrier into that. This is a complete replacement of steam. So thank you very much
Thank you.
for your presentation today.
Thank you.
All right, next up, we have Victus, and we got Katrina Stewart coming to the front here. Are you going to wander, or are you going to use that mic?
That's okay.
Yeah.
And I'm going to apologize. I'm less prepared than I like to be, so I'm going to use some notes.
Just do that.
And I'm actually kind of worried this isn't the right presentation, but we'll run with it either way.
Yeah, it's just the big button there.
Big button, okay. So, hi everyone. My name's Katrina Stewart. I'm here with Civictus. Thanks to CRIN for hosting this. We're really excited to be here. Before I get going, I'm going to start with our name. So Civictus, Victus is Latin for way of life or living, and the C minus makes it all carbon negative. And this kind of philosophy is what drives all of our decision making. So carbon negative way of life or living, and our vision is to be the most positively impactful. Yeah, this is not the right slide deck. So we're most positively impactful company on the planet. I know this is a lofty goal, but it all stems from our platform technology. So enhanced hydrogen recovery, EHR. This is a paradigm shift that turns coal from a source to a sink of CO2. At our core, we produce synthesis gas, syngas, which is a building block for almost all chemical feedstocks, and we can do this without CO2 emissions. We basically take the front end of coal gasification and perform that at a really large scale underground, leaving all of the gross stuff that we normally associate with conventional coal processing in the ground where it came from. And this is a mile underground. We only produce the beneficial gases to surface, and then from there we can process them into a lot of different commodities. Our first product will be clean hydrogen. This is kind of hot in the market right now and has an established 95 million ton market, as well as new and exciting applications with the emerging hydrogen economy. Methanol is actually the easiest product for us to produce based on the composition of our gases, but it's not as environmentally compelling. And while we were researching markets, we actually came across a technology from the 70s that was hugely successful that utilized methanol to ferment bacteria to create single cell protein as an alternate to soybean meal and fish meal. So this SCP, single cell protein, is the ultimate product for Civictus as it allows us to target climate change from both sides, reducing emissions, land use, and water use during our production, and enabling reforestation and removing gigatons of CO2 from the atmosphere. Great. Our biggest competitive advantage is that this isn't a trade-off between what's economical and what's good for the environment. We can produce hydrogen at a cost competitive with gray conventional hydrogen, but with lower carbon intensity than the published standards for clean hydrogen. The industry as a whole is moving away from colors, which is great for us to look at more quantitative carbon intensity standards. And EHR is based on underground coal gasification that was successfully commercialized in the former Soviet Union. We have dramatically updated this and combined it with our own technology for carbon sequestration. We demonstrated this at our site in Alberta in 2021. And our academic partners at the University of Calgary have independently validated that the CO2 stays in place with no material risk, proving that deep coal has a huge potential for CCS. This is a real-world solution that is economically viable and can be implemented quickly and all over the world. Is the animation? Yes, great. So I'll let this. I'll let the animation play because it explains and shows how our technology works underground. We drill horizontal wells deep into coal seams. So for reference, the one in Alberta is over a mile deep. We effectively mine the coal seam with heat and chemical reactions. The high hydrogen content that we produce in our gas actually comes from the saline water in the formation, which drastically reduces the amount of water, fresh water we need at surface. And then as we operate the system at a pressure below hydrostatic pressure, it allows the methane and the water that's in the surrounding coal seam to be mobilized towards the reaction zone. And this effectively creates the space for us to inject CO2 in a parallel well for permanent sequestration. And with support from CRIN, we are building our first ever EHR facility here in Alberta to produce 7 tons per day of clean hydrogen. And we've broken ground on this facility and should be drilling our production wells this spring after the winter season wraps up. Okay, good. The graphic's not too blurry, but this just shows the flexibility of the operations at the surface that we have. So we could operate just as a power generation facility. We could operate just as a pure play CCS, but we can also produce a variety of chemical feedstocks to support challenging to decarbonize industries. All of these options benefit from our dedicated on-site power generation, so there's no need to connect to the grid, and on-site sequestration, so we don't have to deal with costly transportation and infrastructure. Am I aiming? Oh, I went too fast. No, I didn't. Good. So I did start this talking about really lofty goals. And the reason that we can aim this high is the scalability and flexibility of this technology. There are trillions of tons of suitable resource for this around the world. And we have the only technology to utilize this at low cost and low carbon intensity. We can scale rapidly, and we're looking at sites both in Alberta, in Canada, in the States, and we have some exciting almost pilots kind of in the works in India as well. So while we do start with coal, we truly believe this is the opposite of greenwashing. This is turning conventional wisdom on its head and finding a new way to utilize forgotten resources. It's a Canadian technology that will have massive global impacts, benefits, especially as we export this technology. As to China and India that have openly stated they are not decreasing their coal consumption. For context, China is approving 2 new coal-fired power plants a week, and India is right behind. And as much as we might want to advance renewables, the reality is that climate change will largely be determined by coal use in emerging economies. And I think I have time, but a piece of our technology story that we haven't really been bragging or broadcasting about as much here in Alberta is the single cell protein and our industrial fermentation process. So this is where we take the methanol that we produce through EHR and grow a bacteria on it in a continuous reaction, producing high quality protein that's suitable for animal feed as an alternate to soybean and fish meal. Again, this product benefits from our low cost, low carbon intensity with the integration of our upstream technology. But we see this as the most environmentally compelling product that we can make from our syngas. And we just scaled up production, our pilot production to 750 liters this month. Our second run is starting up as we speak right now. And we have support from the Gates Foundation for animal feed trials, which will provide data for our regulatory approvals that we need here in Alberta. And we've also heard that they've just approved a supporting project that will compare our SCP with other SCPs that are existing market leaders. And these will be large on-farm trials in Africa and India. as they see SCP as the best option to support our growing population and small producers in Africa and India, while decoupling land use from protein production. And for the sake of timing, the potential benefits of SCP are enormous. But I'm around for questions later. I'll just leave it up there. I'd love to dive deeper, but I know it's a lot to kind of condense into this presentation. So
I think you're welcome to. You have 8 minutes.
oh, I was worried, so I went really speedy. But maybe I'll just open it up for questions then, because there's lots going on here.
But
It's good for human consumption.
Yeah, so I think the question was, is there any potential for the SCP to be viable for human consumption? The answer is yes, but it's just like a tasteless powder, and so the challenge to, pardon?
Sort of like whey
Yeah.
protein.
So we would love to kind of get into that down the line, but the animal feed market is just drastically larger and a much easier market to get into. So both from a kind of traction perspective, as well as I think it's $400 billion. Like it's a very large market. So we can get into that and get a fair chunk of it. We also see the environmental benefits of taking soybean production away from places like the Amazon rainforest are pretty beneficial. So there are some hurdles to get it to human consumption just from a taste and palatability. But actually, we'd love to partner with somebody else. We'll give them the powder, and they can run away with it and do the fun stuff to make it human consumption. Yeah. So yeah, safety, you can have a spoonful if you want, but
Thank you, Karina. Thanks for the presentation. I just want to circle back to the other byproducts, right? So basically, if you decide to, have your system in a coal power plant and you produce methanol, right? And I'm guessing, so you guys have ammonia. So I'm guessing is it like an NPK fertilizer, or where exactly is a byproduct? And in terms of where to put it in the user perspective, because a coal power plant is way miles away, right? And the users as well. So how do you connect both in terms of distance, logistics, transportation, whatnot?
sure. I don't know if I'm going to answer exactly what you said, but from an ammonia perspective, we haven't gone straight to ammonia. It is a large market for fertilizers and things like that. Actually regulating that and getting that approved in Alberta is challenging. So that's why we started with hydrogen. What happens, maybe that other diagram, back. We need to inject oxygen into our system so we can have an air separation unit. And that's where we get the free kind of nitrogen from, and why an ammonia production is quite plausible is that we add it to the hydrogen that we produce once we start injecting oxygen. I'm not sure if that was your question. Sorry.
No, it does. I understand. So that's where the NH3 for the fertilizer come from. So right now you guys are focused on just hydrogen.
Our first
Okay.
facility is just hydrogen.
Okay.
And the idea is that we have all this flexibility, and when we develop a new facility, we will see what that market needs, what that location, what that jurisdiction needs. So in Alberta, we're starting with hydrogen. We probably won't even do ammonia. We'll go straight to methanol and then the single cell protein here, and have that basically as our flagship facility that has all of the components of our production. But somewhere in the States, like Wyoming, where we're looking at, there's a huge demand for ammonia right kind of down the road. So that might be an ammonia plant. And then maybe somebody in another location only wants us to produce power and take CO2 from third parties and inject that for CCS. So there's a lot of optionality, which makes the storytelling kind of challenging, but it also allows us to, do a lot with the technology. So
Yeah, thank you so much. That answered my question.
Interesting, very interesting process. Bill, I'll check in with Baker Hughes. Just thinking of some past experiences, wondering, do you have any kind of temperatures or pressures where this has to occur at? Because that's what I've seen in the past where in situ, especially downhole, you had heat sinks, you had fractures, you had, non-containment, all those issues around it. I'm wondering, what does this essentially run at?
That's not my exact area of expertise, so I don't have specific temperatures. What we do have to look for when we're creating a new site is that we're the only source for oxygen. So having other wells that go through the formation, we have to make sure that those are either far enough away from our reaction zone so that they aren't interacting, or that they're well enough protected. So these are our coal seam's 12 meters thick. It's the Manville coal seam. It's kind of where the ECBM stuff was going on out towards Big Valley in that direction. The actual area where the reaction is happening is quite small, and we've done a lot of modeling for the impacts to groundwater and the surrounding areas. The thermal kind of radius of it is very small. We're not going to be overheating somebody else's well down the road or anything like that. So that's not quite your question answer, but I tried to give you some flavor for all of that. Yeah.
Okay. I had a second part was that there is a lot of unknowns a lot of times down hole, and especially sulfurs and elements like that. I think you said you work with the formation water actually for generation. Is there concerns around contaminants, metals, whatever's in there, especially if you're going through to a potential food source?
From a contaminant and metals perspective, the area and sulfur, we're not quite worried about those at the moment. The samples of the coal that we've got up have kind of shown us that those aren't main concerns for us. Our founders are the experts from the former Soviet Union program, and this is running for 60 plus years. And they've run about 4 different demonstrations in Western kind of countries. And so they have a lot of knowledge on how to run this so that even if something does happen that's a bit unpredictable, we're confident that we're able to kind of operate through it. Yeah.
So when you were first describing how deep these wells were, like you just said deep, and I envisioned really deep. How deep is deep?
1,200 meters.
Okay.
Yeah.
That was simple. I took more words to ask the question.
No, it's a great question. There's a kind of range that we want to be operating in. So for our CO2 injection, we want to make sure the CO2 is supercritical, because then we can get a lot more capacity. So for us to be deeper than 800 meters is really our kind of minimum for CCS. You could operate this shallower, but you wouldn't be able to get as much CO2 into, or you'd have to use up more coal for it. So 800 meters is where we start kind of
Sweet spot.
Yeah. And then ours is 1,200 meters, so it gives us even more pressure and kind of security above us. So
Okay.
Yeah.
Oh, we are going to do one more.
Thanks for the presentation, Mariam from Etox Energy. You mentioned that you use the technology for different product and markets, which I assume you should have different market price for each product, and it depends on the market, what you do price your product. But I was wondering if in your cost modeling, how sensitive is to the carbon pricing right now, and how is affecting different market for?
So all of our costing does not include carbon pricing. So all of our economics are based on how the process actually works. If we get a number at some point that we feel confident in for carbon, that's just a bonus for us. So it allows us a lot of confidence that this is an economic positive. Yeah.
Okay, thank you very much.
Great, thank you. Sorry for my
All right, second last here is up to the stage, Akona. We have Chetan Deep Singh. Did I say that right? Oh, get it.
Hello and good afternoon, everyone. My name is Chetan Singh, and I'll be representing Kikona Power here today. I think today, out of all, calls for a brief safety moment. So if you're out and about in Calgary today, please be safe out there on the roads. After this very brief safety moment, but very important one, I'd like to say that over the next 10 or so minutes, I'll be taking you through a series of slides that talk about who we are, what we're doing, and why we hope to capture the attention of the general public as well as the market as we continue to deploy and, well, advance and build our clean energy solution. So diving right in, Econa Power was founded in 2017 within Burnaby, BC, with a vision to produce clean hydrogen solution that is not reliant on carbon capture, clean electricity, or water for feedstock. In short, the basic idea was to avoid as many production costs as possible while keeping the GHG emissions as low as possible. And talking a little bit about how we intend to do that, if you look at the picture, the top left picture over there, that's our patented Excalibur reactor that we designed and built in Burnaby, BC. And what that does is we use methane pyrolysis in that reactor to produce clean hydrogen and solid carbon. And we give equal importance to both of our co-products, hydrogen as well as solid carbon. And our value proposition lies in the fact that we can achieve cost parity with the incumbent hydrogen production facilities, technologies like SMR, even when they are paired with carbon capture. Secondly, like I said, our technology is not reliant on clean electricity. And as such, the process itself requires very little electricity to run, and which is why we are able to fare pretty well with other clean hydrogen production technologies that are reliant on electricity, like plasma pyrolysis as well. Next up, we actually don't even require any form of catalyst for our process. So any issues related to catalytic pyrolysis, for example, carbon fouling, are also mitigated. Lastly, we can set up shop wherever there is natural gas infrastructure. And I think that is something that provides a level of versatility that helps in deployability as well as scalability. Moving along, this is our Burnaby facility where we host our Excalibur reactor. It's a 20,000 square foot Class 1 Div 2 test lab that was designed and built over 2022-2023. And since 2024, we've been doing a lot of testing on our Excalibur reactor along with the rest of the balance of plant equipment. And this has been key to advancing our clean hydrogen solution. So throughout 2024, we tested our first generation or Gen 1 version of the Excalibur reactor. And we achieved some great results. We logged in somewhere around 700 hours of system runtime, and we got the results that we did. We saw some steady improvement in terms of our hydrogen yields as well as carbon yields, and also our carbon, the quality of the carbon product that we were getting. However, we were not able to achieve our commercialization targets that we'd set out for ourselves. And that was down to particularly our solid carbon not being, well, good enough. And why that was because we were achieving a varied result in our carbon black production. So we were achieving a little bit of the N990 series, we were achieving a little bit of the N700 series, a little bit of 500, 600. And so the feedback that we got was that we were not consistent enough in achieving a certain series of carbon black. So we were told that you need to be able to either achieve like N990 series or 500, whatever the target is. And so we went back, we did a little bit of an insight, and what we found was that we were not getting hot enough inside the reactor, and we were not holding the products of combustion for long enough. So the retention times were not long enough inside the reactor. And so this basically led us to go back into the drawing board in early 2025, and we came up with a design of our Gen 2 version, or the second generation version of our Excalibur reactor. And so this Gen 2 reactor, which is currently being assembled in the Burnaby facility as we speak, is going to have an expanded capacity of 500 kilograms of hydrogen production per day, up from 200 that we had in Gen 1. And additionally, what we're also doing is we're upgrading our carbon handling facility, so that it allows us continuous operations. So earlier, what was happening was we had to stop our production runs whenever the carbon filter would fill up, and then we had to manually remove the carbon and then resume the process again. It was not the most efficient way of going about it. And so this carbon handling upgrade will allow us 24/7 or continuous operations, and that's something we want to achieve as well. But the biggest target for us is to be able to get better in terms of our reactor performance. So high hydrogen yields, high carbon yields, and consistently achieving commercial grade carbon black is what our target is for the Gen 2 reactor. Right. We understand that deployability of any new technology at a commercial scale is of utmost importance, not only for technology adopters, but for funding partners and investors as well. And to that end, we've been working on studying a commercial scale of 20 tons per day of hydrogen production facility. So earlier this year, we completed a pre-feed study for the same, and the results of which informed the techno-economic models, the LCOH numbers and the LC emissions, as you can see on the graphs down below. And that's something that we hold very dear because that's something that propels our value proposition. And so plans for 2026 are to continuously upgrade the results of the pre-feed study into by using the Gen 2 results. And so that's going to be our focus area for 2026, get the Gen 2 reactor up and running, get results from it, put it back into the pre-feed study and update the CapEx, OpEx numbers, LCOH numbers, LCA emissions numbers, and so on and so forth. 2027 is what we're looking at in terms of our field demonstration units, and 2028 timeframe is what we think we will be looking at when we go fully commercial. I'll move on to the markets now. Like I said, we give equal importance to both of our co-products, hydrogen as well as carbon. And as such, the markets for both present quite exciting opportunities for us. We view markets through two lenses. One is the existing or landing markets, and the second one is growth or future markets. And if we talk about hydrogen, we see ammonia, refining and upgrading as markets that we are targeting and markets that are existing markets. And we're looking at industrial heat and power generation as markets for growth. For industrial heat and power generation, we have done some use case analysis work, again, informed from our pre-feed study. And again, we will continue to upgrade them as we get more results from our Gen 2 reactor, as well as the ever-changing economic landscape. Sorry, I didn't mean to do that. I want to talk about carbon first. Perfect, thanks. For carbon, the carbon black market for tires and rubber is the existing market that we're targeting. And there's future potential for markets in the construction materials like asphalt, concrete, and cement. And so that's something that presents an opportunity for the future for us. And when we talk about markets, I think we have to talk about some of the risks or challenges that we have to face in order to get to those markets. And to that end, first and foremost, I think is reactor performance. I think achieving those results for both hydrogen as well as carbon in terms of yields is extremely essential. And now, in our case, for the Gen 1 version of the reactor, we weren't really getting there. We were kind of limited by the thermal performance of the reactor. Like I said, we weren't really getting hot enough and we weren't holding it for long enough. And so we decided to go in and build the Gen 2 version of the reactor. So that's something that we're trying to overcome at this point of time. And secondly, valorizing carbon, I think, is key to achieving those attractive LCOH numbers and LCA emissions numbers. I was recently also speaking at an online forum hosted by the University of Adelaide, where we were talking about methane pyrolysis and carbon products, different carbon products, carbon black, nanotubes, and so on and so forth. And everyone was of the same opinion that unless and until you can valorize the carbon, until you can put a dollar value in front of the carbon, the processes won't make economic sense. And so to that end, the carbon black markets also demand high quality and consistent morphology of the produced carbon black. And again, this is another critical focus for us as we are developing our Gen 2 version of the reactor. Lastly, capital. I don't think anything works if we don't have enough capital. Any new technology, whether it is clean energy or any other spectrum, you can talk about it. Without capital, without enough capital, you won't get anywhere. And to that end, we've been extremely grateful to our funding partners, and we're very lucky to have them for helping us raise more than 100 million Canadian. And I would also like to thank CRIN for being a valued partner, sorry, and for putting this event here to get together and for allowing us to showcase our technology as well. With that, I'd like to open the floor for any questions. Sorry.
Have you ever considered, I'm going beyond your business model here,
Sure.
but have you ever considered developing the carbon, like you talked about the carbon market needs to be developed, you need to find quality. Have you ever thought about extending your value to your adopters by creating that market for them?
I don't think we want to be able to be called a disruptor of the market. We want to be able to complement the market. And to that end, we want to be able to help or assist the existing market in terms of whether they want to meet their decarbonization targets or whether they just want some additional low CI product for their business. So that's something that we are trying to do and not disrupt the market, so to say.
Thank you. Good presentation, Jatin. So circle back to the market, right? So like carbon black is trending, which is true, right? But there's been some ups and downs, right? And the last presentation, they did a good job by saying hydrogen, ammonia and whatnot. So like Econite, there are other options you guys are looking towards too as well.
Yeah. So certainly, like I said, we hold both of our co-products equally, hydrogen as well as solid carbon. And to that end, to hydrogen markets, we're also looking at ammonia and refining and upgrading. Those are our top targets at this point of time. So yes, the economics make sense if we're holding both the co-products equally and not one over the other. So yeah.
Too close. Hi, Bill Malachek, Baker Hughes. Sorry if I missed it. Is there any update on the pilot facility with ARC Resources, timeline, any challenges with regards to that initiative?
Yep. So not in terms of challenges, but yes, there is an update that we will be pushing it forward by a year, perhaps. And that's because we want to be able to put the Gen 2 version of the reactor into the field demonstration unit. So yeah, that's what the update is.
Thank you. Hi, very interesting. Can you speak a bit more about the actual reactions happening, the methane pyrolysis? I understand that you guys don't require the same level as fresh water as electrolysis, but do you guys require any other inputs besides the natural gas?
Yep. I think I will take you back. I don't really have a schematic of the reactor, but if we look at the top right, so natural gas and oxygen, a little bit of oxygen is what we're putting in just to help the products of combustion sort of to get along inside the reactor and complete the thermal combustion. But we're not using a lot of electricity or a lot of even water for that matter. And we do hope to recycle a little bit of the produced hydrogen back into the cycle, back into the reactor, just to be able to get better overall yields.
Just curious that the amount of water that you produce, does it have a market? Are you guys looking at, or is that just vapor? What's happening with the water there?
Most of it is being utilized within the process for the cool down. Yeah.
And that will be the same at a commercial scale.
Yes, more or less it will be the same. Yes, there's not
Yeah.
much difference. Yeah.
What TRL level are you at? Sorry if I missed that.
We are pre-commercial at this point of time, so I would put us somewhere between 5 and 6.
Okay.
Yeah. Once we have the Burnaby, we did already have the Burnaby pilot up and running with the Gen 1 reactor, but we went in with sort of a redevelopment. So once we have the Gen 2 up and running in Q1 of 2026, we will be back to, I would say, a TRL 6. So yeah.
What are your, from an adoption standpoint, because one of the things I also am, I worked for a CRIN, really got bought into what CRIN stands for, what they're trying to do, and how they're creating a ecosystem for innovators to thrive. For innovators to thrive, there's the adopter side of it. So once I joined BBA, I stayed on with CRIN as a co-lead of the adopter sector working group. So I just mentioned that because one of the things that we're trying to do is continue to understand from different sides what the barriers of adoption are, what adopters are saying, whatnot. So what are quality? You had a quality, you're fixing the quality, the technical side. You've got a market, carbon black market that needs the quality, but that needs to be whatnot. What are some other challenges that adopters are, that you're facing when talking with adopters?
Right. So like you said, so first and foremost, of course, is the quality. And so both in terms of hydrogen yields as well as your carbon yields. So that'll be the first and the foremost thing. The second one will again be the CapEx numbers that you're getting for your commercial level or commercial scale deployments. And hopefully they do make sense once we get to a certain level of TRL level. But yes, the CapEx numbers are a big factor. Hydrogen yields, carbon yields, the quality of carbon product. So if we're able to get the N990 series, say for example, so we would be able to add a certain dollar value to that produced carbon. And then again, if we have, say, an offtake partner that can take away that produced carbon on a consistent basis at a certain number, at a certain dollar value, that would make sense. But if at some point of time we're still not able to get, say, for example, a certain dollar value, then it makes things a little bit hard. So those are the kind of barriers that we're facing at this point of time.
Yes, last one, and then something on top of your question. You mentioned about the challenges what you have with the operator. I want to ask what's the value proposition that resonated the most when you're talking with the operator to convince them to host your technology or adopt your technology for pilot or field tests? What did you saw as the most interesting?
Sure. Thanks for that question. Yes, so certainly when we've been engaged with potential clients, the value proposition question has come up, and most of them like the fact that we do not require a lot of clean electricity. We do not require, so the process itself does not require a lot of investment, so to say. We can set up shop wherever there's natural gas infrastructure, so we can just kind of ship it in over the fence, or just be co-located at a facility that needs to be decarbonized. So that's another one of the things that was an attractive sort of factor for them. Lastly, I would also say that the fact that I already mentioned, I think, about the electricity, but also the fact that overall it makes more sense to adopt this technology as compared to other clean hydrogen production technologies, like, for example, plasma, pyrolysis, or even microwave, for example. And all of that comes down to the fact that there is basically very little electricity requirement. So yeah, that was a few of the things that they really liked.
Okay, I think that ends our time here. So thank you very much for presenting today. All right, next up, we have Steve Froehler from LCO Technologies.
This looks straightforward enough. Thank you very much for the opportunity to present. And I'd like to just start by saying thank you also to the folks at CRIN for their more recent support for a significant project that we've been involved with that has resulted in a fairly significant reduction in methane venting out in the field. My name is Steve Froehler. I'm the owner of LCO Technologies and the inventor of a product called the Crossfire. The other forward button. So I am going to refer to my notes, otherwise I am going to ramble. So first of all, the challenge. Methane emissions remain a major challenge, especially in remote sites without grid power. Methane venting from pneumatics and chemical injection pumps are still an issue. We've done an excellent job to date in reducing the amount of methane from those two particular areas, pneumatics and chemical injection pumps, but still a lot of work to be done. Remote sites that have no access to grid power require some form of energy. They typically would use natural gas from the well as a means of motivating that equipment. We're using solar power, and historically solar power has been considered extremely unreliable in the field. LCO saw an opportunity to create a practical zero emissions alternative and still deliver field performance. This is all about cleaner operations, improved efficiency, and leadership in responsible production. So the platform, okay, it's a unified common platform, okay, our ultra low power consuming, explosion proof common platform that can be used to address 3 different areas of significant venting in upstream oil and gas. Chemical injection pump was the first product that we produced. Gives you very precise control, up to 4 independent injection points, extremely low energy consuming. So in applications where it's been difficult to deal with solar out in the field, where others have failed, there's a high degree of likelihood we could easily address those applications. And we have been. The same platform can be used to be made into a instrument air compressor. So now you're running your pneumatic instrumentation on air, using solar power to compress air, run your instrumentation on air instead of methane. Now you're venting air to the atmosphere. As simple as that sounds, it's really not simple at all. And then there's a vapor recovery unit. This is the latest iteration of the product. You'll see that on the right-hand side. And the units that we've produced have worked extremely well in the field. However, there are issues associated with grabbing gas from the vapor space of a tank that make the installation particularly challenging. And so if you have any interest in that, it's worthwhile actually having a discussion with us. We've made some interesting discoveries since the deployment of this particular product. Lessons learned. Innovation came through testing, iterations in the field, listening to field operations, balancing power efficiency, and industrial reliability was the core of the design challenge. Right out of the gate, we thought we had a pretty darn solid solution. But we discovered over time that continuous improvement is something that never ends. It's never easy. It's never cheap. And like I said, never ending. And balancing power efficiency, industrial reliability, core design, developing a control platform that could scale across products required flexibility, field feedback guided usability and maintenance improvements. True innovation came from collaboration, building something that works in real for operators. Really, the feedback from the field was largely responsible for the changes that we made to. I'm going to back this up a bit. The air compressor has been a real challenge in the field. On the chemical injection pump, we might be on, I think we're on about the 5th or 6th revision. But the instrument air compressor, we're on like the 45th revision. It has been difficult from the get-go, to use solar power to compress air. Okay, solar power is unreliable. Air compression is inherently unreliable or inefficient. So now you've got these two things that get together, and what you wind up with is problems in the field. The feedback that we received from the first installations was that, yes, it's good. It's better than anything we've used. It's still not good enough. And we got that time and time again. And largely it's because you've got operators out in the field that have got more wells coming on board, and they're not allowed to rehire guys. They're not allowed to hire extra guys to do the work. So they wind up with simple tasks like a 15-minute maintenance issue on an air compressor. These are the tasks that get washed off the table. So basically the way it was put to us is, we like what you're doing. We need better execution. We need a better product. We need something that's going to be much longer in between those maintenance cycles. And we've been working on that. We've gone from a situation where we were servicing the air compressor once a month to now we're servicing it once a year. So there's a substantial improvement in performance. And my phone keeps shutting off. So, okay. Come on. All right. So what slide is this? This is 4. Okay, so I'm going to go right to the next slide. Am I just not holding my mouth right or something? Come on, baby. All right. So looking ahead, Crossfire platform continues to evolve towards smarter, data-driven, zero-emissions operations, integrating data tools into real-time systems of monitoring for monitoring and performance insights, supporting producers as they move towards standardized zero-emission sites, scaling Alberta-made clean technology for national and global adoption. Just got back from the UAE, had a great trade show over there. It went extremely well. The goal is to make zero emissions operation an industry standard, not the exception. Okay, so with respect to the data, one of the things that I think we're going to see in the industry is demographics are going to catch up to us. A lot of the folks in the field are my age, and there's not going to be that many more years left in these guys before they're going to take a hike. Okay, so when that happens, what are we going to do? When you look at the number of guys that are closer to my age that are going to retire, what is it going to take to fill those spaces? And I don't think we got it. I don't think we have enough space in NAIT and SAIT and the other colleges that are training on things like power engineering to fill those spots. So the only option that we have is automation and data. Keep these sites up and running using data instead of using guys who routinely go in the field just to check on these sites to find out there's absolutely nothing wrong with the site. So they carry on to the next one. And the percentage of time that's wasted in doing this, there was an excellent presentation that was put on by Murphy Oil down in the United States. And they actually invested a bunch of money to determine just how much time the operators were wasting in the field, just visiting sites based on routine. And it was 40%. So, I mean, if you could automate it and you could save that 40%, I think you're heading in the right direction. So recognizing that, we've always been working on trying to develop solutions that include data-rich solutions. Okay, so why it matters. The Crossfire platform delivers measurable impact for people, industry, and the environment. Every unit prevents methane emissions and recovers value back into the production. Operators save on chemical, fuel, maintenance, traveling back and forth to the field, and helps you to improve your ESG goals. Data, your information, like how much did you not vent, that's based on data. And we give you that in our platform. Designed and built in Alberta, showcasing local innovation in action, demonstrates that environmental progress and operations performance go hand in hand. We have folks that have taken our chemical injection pump and have put it into installations where they've paid for the equipment just with chemical savings alone. Most chemical injection pumps go in the field, you set them, you hope you set the rate at the right level, and as production goes up and down, you're either under-injecting or you're over-injecting. By automating it, you maintain the chemical ratio relative to the production, and you can pay for this equipment just in chemical savings. Forget carbon credits and things like that. If you save a couple of trips and, for an operator, plus you're delivering the right amount of chemical and through automation, you can easily justify the expense associated with integrating this into your SCADA system. Thank you very much for your time. If anyone has any questions. Thank you.
Anyone got any questions right off the bat here?
Okay. Great trip to the Middle East. You getting serious about methane venting?
Good to hear. That's good to hear. Solar. Talk to me about your solar system and how do you keep your uptime to a max?
Okay, so the only way that, when you look at Alberta, a lot of our oil and gas producing area or territory is in northern Alberta. And the farther north you go, of course, the more difficult it becomes to exploit solar energy. So there's nothing wrong with the solar, the panels or the batteries. It's the type of equipment that you're trying to run with it that is the challenge. So with our chemical injection pump, for example, I can inject 25 liters a day into a 1,000 PSI production line, and I do that with 6.6 watts. That's 1 watt. So that's extremely low energy consumption. I can run 2 or 3 wells, depending on how old the wells are. If these are new wells where the dump valves are stroking once a minute, okay, it might be 2 wells. But I can run 2 or 3 wells with a single air compressor, and I'll run with less energy than a 100-watt light bulb. So that being the case, it makes solar a viable source for energy even as you go further north. Now, generally speaking, we're not the only equipment that people are trying to run off the solar arrays. I've been out to a couple of sites where, I was staggering the size of the solar arrays, but they're also trying to run a bunch of other equipment besides ours. But generally speaking, for some of the older legacy systems where you're dealing with 1 or 2 wells or 3 wells, maybe on a small frac pad, and they're a couple of years old, your dump valves are stroking once every 5 minutes, that compressor's hardly going to know it's running. It's going to be extremely low energy consuming. So this is how we have, brought that, the usefulness of solar back into the realm of possibility. Where historically it's been, you say when I first started this back in 2017, solar powered chemical injection pumps, I don't know a single operator anywhere that had a positive thing to say about solar powered chemical injection pumps. Generally speaking, they were considered extremely unreliable. I think we've done a lot to change that.
Wonderful. Okay, speaking of your customers, are
Yes.
you allowed to name the names of people who are now switched their opinion on solar powered pumps? Chemical pumps?
I'm going to be honest with you. I think that, and they're basically all the major players. Tourmaline, Shell, Cenovus, CNRL, they're all very good customers of ours. And they've been extremely patient with us. The gentleman who actually set the objective, really set the objective for me, was a gentleman from CNRL up in Grand Prairie, Brad Coker. And I owe him a lot because he basically sat me down and said, if you can't fix this, basically get lost. So, because they were just going to run their instrumentation on methane. So, but he loved the idea. We just needed to make it better. And so that really drove us hard. Now, I'm going to also say that this is something where the carbon tax motivated these folks. I mean, if it hadn't been for the carbon tax, I don't think that a lot of these folks would have gone nearly as far as they have. I'd like to think that everyone talks a big game about being focused on the environment and everything, but when it comes to putting your money where your mouth is, generally speaking, it's, shareholder value comes first, and environmental is always considered an expense. Okay, so how do you make it, there's got to be more to it than just the carbon or the methane venting. There's got to be performance related improvements. There's got to be data. There's got to be something else that's going to make it compelling for an end user to adopt this kind of technology. It's not enough to just pump a chemical. You have to pump a chemical and you have to give data, and you have to be able to report on your status, and you need to be able to make it so that you don't have to go site as often. So.
Okay, anyone else? Yeah, we got one down here. Perfect.
Hi, Steve. Thanks for that. Paul Ashford. At a previous role I was in, we were one of the early adopters of the LCO Crossfire, and we ran that off of thermoelectric generators because we were a little bit concerned about whether the power was a viable option or not. Any comments on, is that still an option that's being done at all as an intermediate between still saving off of methane venting, but not getting down to zero emissions, but lower, but something that maybe you don't have the same reliability concerns that you might have with solar?
People are using tags all over the place, and they're using them to support or back up the solar. Generally speaking, what I see is a hybrid systems with tags and solar. So in the dead of winter, depending on how far north you are, when you're north of Grand Prairie, we're dealing with 4 hours of daylight. And from 4 hours of daylight, the customer wants our equipment to run for 5 days from 4 hours of daylight. That's a big ask. Okay. We can pull it off if you give us enough solar and you give us enough batteries. But I mean, even at 6 watts, running 24 hours a day, 7 days a week, that's still there's some watt hours there that you need to be able to accumulate. Hard to get when you only have 4 hours of daylight. So generally speaking, what we see are tags or fuel cells backing up solar, with colossal solar arrays. So you look at that, there's a bona fide commitment to, trying to get their emissions down. I mean, you wouldn't do that unless you were pretty serious about getting your emissions to zero. For CNRL, for example, the part of the reason they were so committed to it was because they were able to just completely do away with their fuel gas infrastructure in their skids, which saved them a bunch of money on the production of their skid. Okay, but it meant it better not fail. Like when once you've done that, there is no switching to fuel gas in the event of a failure. So it better not fail. And, that's where they said, the once a month thing for 15 minutes, don't have that time. So figure it out come back when you've got it figured out. And we figured it out, and now we're doing the job.
Okay, we will do this really quickly.
Are you guys using bifacial solar panels?
We leave the solar panels in the hands of others. I mean, we supply the equipment that we showed you here, and that's basically it. We don't do the solar panels. All we say is, based on the operational information that you can give me, this is how much energy I require. What panel you use, that's your business.
Okay, thanks.
Okay, thank you, Steve.
Thank you.
Okay, I think now is our last one. Lindy was reminding me that we had 3 when I was mentioning we had 2. Okay, so today we have Jeff Newbecker. Did I say that right, Jeff? Yeah, and he's with Aerolytics. Thank you. Welcome to the stage.
Okay, thank you, everybody, for sticking it out the last one of the day. Tough roads today, so I hope everyone gets home safe. Yeah, I'm a soft talker. Okay, yeah, so everybody, my name is Jeff Newbecker from Aerolytics. Today I'm going to walk you through a solution that we just released called Aero IQ, and it's our SCADA based emissions intelligence platform. And I'll show you how operators are using it to detect, calculate duration, quantify, and understand in real time root cause without installing any new hardware. Let's see if I can do this right here. Yeah, good enough. Okay, so Aerolytics is a team of industry and regulatory experts, data experts. It's been around for about 8 years. I've been there for about 1 year, but prior to that, I was 20 plus years at a upstream energy company. So I am moved to the dark side of the vendor. It's been an interesting journey. Yeah, so our platform has 3 pillars. The first one is an OGMP reconciliation framework. It's a code-based, delivered through consulting, affordable reconciliation framework. The second is AeroViz. AeroViz is our a measurement and LDAR workflow software solution. And then the third, which is the one I'll talk about today, is Aero IQ, which is an emissions continuous SCADA-based digital monitoring solution. There we go. So why do we exist? So our focus is really simple. We're incredibly strong supporters of the Canadian oil and gas market. We want more of it. We want it to be cleaner, and we want Canadian energy to be more profitable. So our thesis is emissions are a leading indicator of operational health. And if you manage it strategically, we really believe you can both reduce environmental or improve environmental performance and improve business performance at the same time. They don't need to be in competition with one another, which they often are in the real life. So who do we work with? We work with lots of companies, everything from super majors on both sides of the border, all the way down to little juniors, public and private. Okay, Aero IQ. So what is Aero IQ? What it does is it turns your operational SCADA data into a digital monitoring system. Traditionally, emissions might be detected through things like infrequent LDAR inspections, periodic measurement surveys, perhaps SEMs that you would detect after the event happened. It could be during a regulatory or third-party inspection, which is never too great, or not at all. Sometimes we just use emission factors to calculate emission events. So Aero IQ is different. What we're doing is we use that operational data that you already have. We use like pressure sensors, flow sensors, level sensors, temperature sensors, binary valve positions, whatnot, to detect emissions, calculate the event duration and the volume, and most importantly, understand why they're actually happening so that you can actually take a really strategic approach to your abatement efforts. And we're not just looking at the emissions, we're actually looking at the operational health of your facilities. And what this means is that you're identifying emissions immediately, not hours or weeks or months later, like immediately, and you understand why they're happening. And then finally, we've been able to actually test some predictability, which is really cool. We've been able to get 80% accurate in just a couple of model iterations of our learning model on several flare and tank emissions, depending on specific root causes. So imagine a world where you could actually take action before the event even happens, either through a process improvement or a small investment. Okay. When you understand why, not just why, or when you actually understand why an emission event occurs, not just that it occurs, you can do some incredible things with it. You can reduce flaring, you can optimize your equipment, you can detect unlit flares, you can prevent tank emissions, you can reduce manual reporting, you can optimize your assets. And so what this results in is a combination of lower emissions, lower operating costs, and higher production uptime. And we consistently see sort of 6 use cases when we're talking to operators in North America. The first one here is unlit flares. So what we can do is we've actually been able to detect unlit flares with no added sensors. Most operators rely on thermocouples or multiple thermocouples, backup thermocouples, or expensive flame detectors like cameras and whatnot. Aero IQ can determine whether that flare is unlit or lit using only facility data, reducing hardware requirements, and catching multi-hour unlit flare events before or earlier on. We detect flare events with or without a meter. We can categorize those events and explain why precisely they occurred, enabling clear abatement prioritization linked to whatever is important to your company, whether that's economics or safety or ESG, whichever way you want to evaluate those projects. Tank emissions, thief hatches and PRVs, even without tank pressure sensors, Aero IQ can detect whether a leak is approaching set point, a leaking through an approach to set point, a full release, or perhaps it's a failed reseat caused by something wrong with the seal like grit or sometimes they can get grime in them. Compared against SEMS, we've consistently been able to detect all of the same events, often 10 to 30 minutes earlier. And we can catch smaller releases that fall below minimum detection limits. VRU equipment and optimization, a big one for cost improvements by understanding throughput, things like suction pressure, flow patterns relative to the emission event. Aero IQ has been able to optimize VRU and other rotating equipment to reduce emissions, increase recovery, and lower costs. Stationary combustion. Beyond methane slip and seal emissions, there's also significant opportunity to reduce power costs by optimizing load profiles using SCADA-derived insights. This is a big project for me personally in the Bakken for about 10 years. And then replacing manual reporting for things like pneumatics and blowdowns. A lot of these emission sources use emission factors. We can actually isolate the section of the facility that's being blown down or pigged. And we can calculate actuation of pneumatics through flow rates. Okay, so our approach to root cause analysis. So this is the proprietary root cause engine of our Aero IQ. What it does is it analyzes every single emission event, and then it creates 3 levels of root cause. The first level is what is that piece of equipment that created the emission, a tank, a VRU, whatnot. What is the operational context? Like, why is that piece of equipment acting the way it's acting to create that emission? And then 3, what is that underlying operational event that's happening upstream of that piece of equipment? And with those 3 things in mind, you can really create a focused abatement plan, targeting exactly what you want to target. And what it also allows you to do is identify the conditions. So is that flare unlit? Is it a co-venting situation? What is the categorization? Is it routine? Is it non-routine? Is it persistent or intermittent? Is it high flow or low flow? And you can really create a really great story around what you're trying to abate. Okay, here's a case study. So this is a graph we call a cluster graph or a fingerprint graph. We think it's unique to Airalytics. It's proprietary to how we sort of think about emission events and root cause. So basically what our model does is it looks at events and then it categorizes those events into like-caused operational conditions. And it can very clearly group them. So, you know, in this example, this is 6 months worth of a client's data for every single flare event that happened. So those dots they could have been a second long or they could have been an hour long or a day long. But we group them into like-caused events. The axes don't mean anything. They're 292 SCADA tags that were evaluated that we're just condensing it into an X and a Y. And then the model creates a thesis or a theory around what actually happened based on the SCADA tags. It's validated either by the client or by our in-house specialists. And then once 1 or 2 or 3 events inside each of these clusters is identified, going forward, every single time an event happens that looks like one of these clusters, that root cause process is already done for you. And so we're eliminating the root cause process from literally hundreds of hours of work to zero through the AeroIQ. Let's keep going. So this is an example of tank emissions and how AeroIQ is looking at or interpreting that SCADA data to understand why tank emissions are happening. So this was a client that had a tank farm, and they had a PRD and they had a thief hatch on each tank in the farm, but they didn't have pressure sensors on the tanks individually. They had one group flow event pressure tag, and then they also had some level pressures inside the tanks. And what we were able to do is 100% of the time, we could identify an event that SEMS identified. And we could actually, without the pressure sensor on the tank, just through inference and correlation amongst SCADA tags, we could identify the tank that actually released. And then as we removed data points out of this or SCADA tags out of our analysis, we're able to also, with very high accuracy, continue to detect those events, whether they were a reseal problem, a full release, or a leaking as it approached that point event. So the point is that what we found was that we didn't actually need as many SCADA tags as people might have thought they needed. They didn't need to install new ones. We could infer through correlation events on location. And then we could look backwards or upstream and we could actually figure out what caused that. Oh, that's it. Look at that. So AeroIQ, it gives operators a real-time emissions monitoring layer using only your SCADA data, providing detection, quantification, and root cause analysis and operational context on every single event. And I'm happy to answer any questions if anyone has any. Thanks for listening.
Hi, great presentation, very interesting. I'm just curious, it sounds like this could be applied to other industries besides just looking at methane releases. Is that something you guys have looked into? Is that true? Because we're developing a plant, we have hydrogen, we have CO2 moving around, and knowing if that's been released is both good for our production as well as safety and things like that. So just curious if it could be applied to different industries. Yeah.
Short answer is yes. We are looking at different industries and how we can apply this machine learning intelligence essentially to optimize assets. Yeah, exactly. It's interesting. We oversharing here, but we almost had a bit of an existential crisis the other day around like, are we an environmental company or are we an optimization company? And it's an interesting question to ask. I would say we're an optimization company with a spin on looking at emissions strategically, but I think that's transitioning into let's just help companies be better.
I know Liz, so tell Liz I say hi.
Okay, I will. All right. Katrina. Okay, I will. She'll be judging me on this, I'm sure. Someone videotaped it. Tell her I did a great job. Yeah.
So is this just pulls from your SCADA data you're already collecting? Yes? Yes? Did I just state the obvious on there?
Yeah. So there are some Yeah, so we're working with a client in the US right now, and one of the things they really wanted to understand was pit flares. And unfortunately, with a pit flare, they were built so long ago, they just don't have information. So you need something. But if you have something, it's incredible what you can infer through the data. Like Steve had mentioned earlier, he did a great job, by the way, really good presentation. Inspired me to talk about value, because I agree with you. This concept of paying for just emissions reduction, I think is going away or gone. You need to also really articulate ROI, really articulate operational value. Yeah.
Do you think that you fully articulated the ROA? Would you like to take a moment to do that?
I would, so emissions reduction. So, I think we're all here because we want to reduce emissions, but ultimately, I talk to our staff. We have staff and they're young and they're inspired and they want to help the world and the planet. And that's great. But if we're not providing ROI to the client, we can't do the other thing. So there has to be ROI. So when we look at ROI here, we actually just built a case for a prospective client that we're working on. So things like windshield time, certainly that's a big one. Operator time, if you can help an operator reduce the amount of effort they have to put into manual reporting, for example, or root cause, huge. Like they have better things to do. And I mean that with all due respect to the root cause analysis process. Like they're operators that just want to produce more oil and gas. So if we can save them time, that's huge as well. Obviously, like the tier liability program is a big contributor to ROI for some aspects of this. I would say we hesitate to tie our ROI to a government carbon price. I think that can be scary. I think it needs to stand on its own. So for example, oftentimes what we find with flare management is beyond the obvious importance of reducing flare emissions, you're actually improving uptime. Your resources your F&Ds go down, your unit OpEx goes down. There's tremendous opportunity operationally outside of the obvious benefit of emissions reduction. I don't know if I did a good job. You'll have to judge me after on that one.
Oh, I'm not judging. It is actually the Clean Resource Innovation Network.
That's right.
So it does combine everything, but really it does go to optimization and what optimization might mean to you, what that, mind map looks like for all the things that you just mentioned that go into ROI, and as a benefit or maybe as a focal point where people can rally around is emissions reduction, land use reduction, water reduction, et cetera. So
yeah,
we'll go over here to Kate.
Hi, Kate.
Hi. When you get a new client, how long does it take you to kind of get set up and get the data integrated into your system?
Such a good question. So as our model, we have an interesting predicament because we feel very strongly that we cannot and will not share learnings between clients. Very important for us. Data security is by far the biggest hurdle with bringing people on board by far and away, especially with SCADA data. It's interpreted as very strategic. So we have this interesting conundrum where we built our ML model that learns off of other data, but we don't want to share amongst clients. So there's always a bit of an onboarding cycle. So our onboarding cycle typically runs anywhere between 3 and 9 months to onboard the data. But what's happening is we're finding improvements in things maybe that we didn't actually think maybe we'd find improvements on, such as data cleaning, such as intermittency in data. Like there's a lot of challenges around that data that took a long time to onboard clients with, and now we're finding that we've solved those problems. So that's happening quicker.
It's kind of like collaboration, but not like, would you say that? Like you're not sharing the client data, but you are kind of learning off of each other's data.
Yeah.
So it's a collaboration behind digital doors.
Exactly. But it's our CPO would do a better job explaining this, but there's a difference between methodology and sharing data across clients. And so we build a methodology without sharing data across the clients.
Wonderful. Okay, well, that wraps up our day today. Yes, Lindy? That's correct. I did that right this time. I want to thank all the presenters today. On behalf of CRIN, we are extremely fortunate to have innovators that are super engaged, that show up on these, well, it's not even snowing anymore. I haven't looked out there, but
Beautiful.
on these extremely snowy days, joining us in person. And, as a adopter of this, really appreciate that. Well, I came from oil and gas company for a very long time, so you can probably, attest to this. Is we find a lot of problems at a producer operator, but we have some really cool ideas about how to solve them. But sometimes we're not empowered to solve them, and it is really nice that we can work with innovators like yourselves. That you have the capacity, and you have the tenacity to solve the problems that this industry needs. So have a wonderful afternoon, drive safe, and we'll see you tomorrow. We'll see you tomorrow. Thanks a lot.
Thanks all.